All right, well, hello class. This is another quadratic equation. Or sorry, actually, it's not really a quadratic equation yet. That's a foreshadowing. We see this equation here, and they ask us to find all the solutions that are within this interval from 0 to 2 pi. So that means when we end up graphing it, we only really want to look for any solutions from 0, or from pi, over to 2 pi. Only solutions within that interval, nothing outside of those. Okay, so at first glance, I have to admit this question seems really tough to do. I mean, of course, we could look at our calculator and get an answer, an approximate answer right away. But algebraically, there's a bit of a trick for this one. I wanted to kind of show it to you. Nothing too special, but it just seems to work really well. So check this out. What would happen if you squared both sides? Doesn't seem that interesting yet, but you'll see what happens as we do that, that something good happens. It allows us to solve it. So let's see what happens. So first step is cos x plus 1. Cos x plus 1 equals sine squared x. Okay, no problem. Expand those brackets. Cos squared x plus cos x plus cos x plus 1 equals sine squared x. All right. Still got a bit of a problem because we have cosines and sines all mixed up together. So let's try to avoid that problem, and let's go to our formula sheet really quickly, and we see on our formula sheet that there's an equation that looks like this. How do they write it? Sine squared x plus cos squared x equals 1. And if we rearrange that and we say sine squared x equals 1 minus cos squared x, well, this we can then replace with sine squared x. So that's kind of a little tip from your formula sheet. It makes things a little bit easier. So on the left side, we've got cos squared x plus 2 cos squared x plus 1 equals 1 minus cos squared x. Okay, so this guy and this guy both ended up here. All right, so now we've got a bunch of like terms, or not a bunch, but some like terms. Let's put them together. We've got 2 cosine squared x, and we've got 2 cos x, and the 1 and the 1 look like they cancel. So there we go. So now it truly is a quadratic equation. Actually, it's been quadratic since we squared them. And now it's time to solve this thing. So with any quadratic, we always think about factoring first. So I see a common factor there of 2 cos x, and that leaves us with cos x plus 1. All right. So now it's looking a little bit better. So basically now what we have is either cosine x equals 0. Actually, I could say 2 cosine x here. I could write it like that. But I'm not going to write it that way because I know that I can just divide both sides by 2, and so I don't have to worry about that 2. So there it is. So that's one equation, and the other one is over here, and we have cosine x plus 1 might also be 0, which means cosine x might be negative 1. So we basically have two equations. All right. Well, if I go back up to my graph at the top here, this is the cosine graph. Let's see. Cosine graph starts up here at 1, and it goes down. It's got a minimum value at pi, and then a maximum again at 2 pi. So we're looking for any solutions where cosine x equals 0. So it looks like we should have one here and here. And if you weren't sure about that, just double check over here. Oh, I've already got some of the stuff circled on my page here. So here's again cosine 0 at pi on 2, and cosine is 0 at 3 pi on 2. Okay, so we've got those ones. So I should probably write that down. I should say x can be pi on 2 or 3 pi on 2. And then the last one comes from here. We have cosine x is negative 1. And so that should be, here's negative 1. So there's cosine x negative 1, so it should be pi. And again, if we look at our unit circle, we also see that cosine negative 1 happens when the angle is pi. Okay, so we could say it like this, or pi. So it's basically any of these solutions, 1, 2, 3. Now, here's where the tricky part comes in. See, with that trick, when you square things, sometimes you might end up with what they call extraneous solutions. I'll write that word down. I'll write it down in a minute. So we have to double check to make sure these solutions actually work. And let's just try them out. So we have to try each and every one out. So let's try, first of all, this first one. So we have cosine pi on 2 plus 1 equals, I'm going to put a question mark here, sine pi on 2. Okay, so is that true or not true? Let's try. Cosine pi over 2, double check your unit circle. Cosine pi over 2 is 0. Okay, so we have 0 plus 1, and I'll put a line here, and sine pi over 2. So the sine of pi over 2, I've already kind of destroyed it up there. Sine pi over 2 is, whoops, sine pi over 2 is 1. So back to our screen. So equals 1. So 1 equals 1, and yeah, it's true. Okay, so this one, we're good. Check. That one works. Okay, let's try the same thing with each one of them, and I'm sorry, I'm just going to erase this. So if you want to see it again, just rewind the video. Let's try this again. Same thing. I'll try this. Okay, cosine 3 pi over 2 plus 1, and does that equal, question mark, sine 3 pi over 2? Okay, well, I'm gonna go a little bit faster here, so you can check your own unit circle. Cosine of 3 pi over 2, that is 0, and we have plus 1, and that should be equal to, question mark, sine 3 pi over 2. But sine 3 pi over 2, wait a second, sine 3 pi over 2, that's down here. Sine 3 pi over 2 is negative 1. So we have 1 equals question mark, negative 1. I mean, that's not true. Whoa. So even though we did everything correctly, we didn't make any mistakes here, that's what they call an extraneous solution. I'm going to write this word down. Extraneous solution. Okay, so not true. Wah, wah, boo. Okay, and the last one. Let's do this real quick. Maybe I'll save some space and time here. Hope this video is not getting too boring for you. You probably got it all figured out by now. And if not, you can always rewind, double check, check with your friends, check with your teacher. There we go. Okay, so let's erase all this stuff. And let's go to check the last one. So cosine pi and sine pi. So now we're doing this guy. Okay, so let's see. Cosine pi is negative 1. Here we have plus 1. And is that the same thing as sine pi? Well, sine pi is equal to 0. Indeed, 0 equals 0. So this one's good to go. So what is the answer? X equals pi on 2 and comma pi. That's it. Nothing else. And should we just double check with our calculator? I mean, I feel confident already, but I got extra time, so let's just check this. Check it out. Here's a. Let's see. Can I get this thing down? There we go. There's our calculator. So let's just graph this thing real quick. The original equation, I've already put it in there for you. Cosine x plus 1 minus sine x. And I'm going to go zoom down to number 7. It gives me a trig window settings. There it is. So when I do trig window settings, what you have actually, the x minimum is negative 2 pi, and the x maximum is 2 pi. And so what we have here, we can see the two solutions. This solution right here, if I trace along, this solution at this exact point is pi on 2. 1.57 is approximately pi on 2. And then we go over to here. What should it be? Well, look at that, 3.14159. That is pi. So those are the two solutions, and you can see we don't have any other solutions. Only those two from 0 to 2 pi. So we're correct. Yay. So you should feel good about yourself, give yourself a happy face, and you can write down yay as well. All right. Have fun. See you later.